There are two tools you can use for STM32 microcontroller programming. The first one is STM32 Cube MX. This one is just only a C code generator, so you cannot compile or edit or debug the program. For that, you need to have the Kale UVision or Kale Microvision, that is the compiler tool. So when you choose to use this STM Cube MX tool, you need to install extra other softwares like the Scale UVision and so on. The other choice or the other option for microcontroller programming is another tool, that is STM Cube IDE. This tool has already integrated compiler, so it's very easy to download and install and start to use as a beginner. STM32 Cube MX is a graphical tool to generate C code, which is based on standard libraries and peripherals initialization in STM32 microcontrollers. So it means like you will see the graphical view of the microcontroller. So you can set up the pins and peripherals for each input output pin. So when compared to 8-bit microcontroller, you remember this is a 32-bit microcontroller. This STM32-bit microcontroller has so many peripherals. Of course, it's quite complex to configure manually. So that's why we have to use this graphical tool to do the configuration. And also reading registers from datasheet. So all these things, if we want to do manually, it's going to be more complex. So we will use this tool to do these configurations and initialization. So when you generate the C code will already have all the initializations and configurations of peripherals. So you just go to the user defined part and you can include your application code. So of course, if you use this manual configuration, you can assume that the learning curve will be exponentially complex. That is why we are going to use some kind of tool. Therefore, it's a better choice for beginners to work with STM32 microcontrollers. So I recommend two tools and you can decide which one you would like to use. I will go through both tools slightly. I will introduce both tools. In CubeMX, we can select a specific microcontroller or microcontroller development board. We had seen different types of microcontroller families under ST Microelectronics. So they have a M0, M3, M4, and M7 different types of cores they are using. And we are going to use this STM32L4 series. And it has the clock speed of 80 megahertz and 100 DMIPS. So I mentioned about what is this DMIPS already. So please remember in this, once you open the tool, you have to select the correct board. This is the Nucleo board. They also have the discovery board and evaluation board. So we are going to use Nucleo board 64. Okay, so you have to select a specific microcontroller, which one you are going to use or which one you are going to connect in your PC. That is the hardware you are going to use. And the development board, that is the Nucleo 64. And then configure its peripherals, input, output, and also the clock trees and so on. So you have to install this, configure this RTC, real-time clock, and then the crystal clock or CC. And also you have to install other peripherals, the GPIO, general purpose input output registers. And you have to also configure ADC, DAC if you are going to use that in your application. So it's based on the application code you are going to create. So everything is you are going to do in the GUI, that is the graphical user interface, instead of doing as a C code programming. So it's much more easier than the C programming, the one you had done in your first year or second year, I think. So we can even calculate the power consumption of your application in the microcontroller. There is a provision for that. So remember, STM32 CubeMX is very useful to generate C code. but not for editing. So you cannot do the code editing or insert application code, and its compilation and also its debugging. So you can only generate the C code by using CubeMX. So you need an IDE, that is integrated development environment. So there are so many different types of IDEs you can use that is available. But in this course, I recommend you to use Kale UVision. So this is one of the IDE where you can compile and debug the C code. There are some other IDEs are available as well, but it's up to you which one you want to use. The result is the same. So you are going to generate the C code by using CubeMX, and then you are going to edit and debug the C code using other type of IDEs. So Kale UVision or Kale Microvision. So we can simply call this as a Kale UVision is one of the IDEs. It can be used for all or microcontrollers. So in the future, if you change the microcontroller to some other company brand instead of ST Microelectronics, still you can use this Kale UVision for C code editing. So Kale UVision is the kind of most commonly used IDE in the hardware or firmware programming. Okay, so of course, not only for ST Microelectronics, if you use the microcontroller from other companies or other vendors like Atmel, NXP, or any other ARM-based microcontrollers. So I recommend you to use Kale UVision IDE, and it's a good time investment. So you will reuse this knowledge again. Yeah, the same thing what I said, because in the future, if you move to another ARM-based microcontroller, you do not need to learn new IDE again. You can still use the same Kale UVision. So now we will see how to do downloads and installation. So the one we are going to use, it's STM32L4 series. So this is mainly for ultra low power applications generally. So why we use this Cortex M4? The reason for using this hardware in our project, it has floating point unit, and it has a logic to decode and execute instructions, and data computation performed by ALU, and results are generated quite fast with ultra low power, and it has many registers to store and manipulate data, and it has pipeline engine to boost the instruction execution. Pipeline means like it can execute instructions in parallel, and it has a hardware multiplication division engine, hardware based, that is also based on the ARM core, and it has address generation unit. There are quite some advantages. Out of all these advantages, please remember this floating point unit. This M4 has a floating point unit, so it can really perform the high speed computation, even though it's ultra low power. So high performance is here in this third row, but in this ultra low power, you can also achieve quite good performance. Of course, if you use this microcontroller in some critical applications, then you really need a very high performance. Then you have to choose some other kind of series, for example, F7 or H7 series. But for this kind of beginners project, this is good enough, L4. Okay, so here, as I mentioned, like here, there are 3-stage pipelines. So here you can see how the pipeline is working. So fetch, decode, execution, these are going in parallel. And this one has a floating point unit, as I said. So this is mainly available in M3 and M4 cores. So here you can see M3 and M4 cores.